Hello everybody, and welcome to my craft overview of the N1L3 Soviet moon rocket. Right now, we're taking a look at the NK-15 engines on the first stage, of which there are 30. Right now, we can see that they are below a fuel tank, which I used a fairing to cover over and get its shape. Now we are beginning to take a look at the second stage with 6 of the same NK-15 engines vacuum optimized for higher atmospheric climates. This will be used during the upper climb phase of the mission, or technically the mid-climb phase. And now up to the upper climb phase stage, this will still be used on a suborbital trajectory, which means you're not entirely in orbit yet. The stage has 4 engines. They are different engines, and again, I used a fairing to get its shape. There is a single fuel tank below it. As you can already see, we're taking a look at the fairing of the vehicle, of which you can see under that is the 4th stage, which is used to get us into orbit and is also used to get us partially on our lunar trajectory. In some missions, if you're really fuel efficient with it, you can actually take it on a full translunar injection and orbital trajectory. Now, the stage above that is the 5th stage, and the 5th stage is used for the orbital burn, like going around the moon, and parts of the landing burn, so that way it has the LK, which is the module you see above it, has a safe window to get down to the moon safely and do all the stuff it needs to do on the surface. Above that is the service module of the workhorse of the mission, known as the Soyuz. By workhorse, I mean really the module where all the crew spend their time. The Soyuz was somewhat of a research station and capsule that would be placed in orbit of the moon, and the LK would dock with it and meet back up with it, so that way all crew could get right back to the surface of the Earth. Above that, I used a payload fairing to keep this all, encased and not looking ugly, which is what they did as well, just to protect it from the harsh conditions of the atmosphere. Above that, we had the launch abort system, which was used to pull the capsule away in any time of peril where the rocket had an unexpected, rapid, unplanned disassembly. Or just big rocket go boom. Wrapping up our craft overview, we will be taking this to the launch pad and seeing it in action. And here we are at the launch pad, where, as you can see right now, the N1 is just lifting off the pad in what would have been a historic event for the Soviets to remember. Right now, we are on the first stage, also known as Block A, or A in Russian. At this point, it would have just lifted off the pad and would already start beginning its gravity turn. A gravity turn is a trajectory that a vessel must take, especially a vessel that is going into space, must take in order to get a good trajectory so that you have time to do an orbital burn. So that way you can just go around the planet endlessly. On the left, you will see our fuel gauges and the rapid rate of consumption of this fuel. On the bottom, you will see a navigation instrument, of which is called a nav ball. This is just to show where all your markers for which way you're facing are. And in the bottom right, you will see that we have some crew members on board. These are Valentina and Bill Kerman. These are not accurate to the real astronauts that would have been on board the N1, just to clarify. Right now, we have just jettisoned from our first stage, and we are now on Block B, or the second stage, which, as I said earlier, has 6 vacuum-optimized NK-15 engines. Right now, we are about to jettison the fairing and expose the lunar complex beneath. And here we are jettisoning the fairing. As you can see, we have the lunar complex below it, with the launch escape tower on top of that. We are about to jettison our second stage and move on to Block V, which is now switching over to numerical order, or Block 5 in Russian, or in English. We have just jettisoned the launch escape tower, and right now we have our 4 vacuum-optimized engines on the bottom, trying their best to take us up into orbit, although these will end up crashing back into the surface. This stage is very fuel efficient. It will take a lot of time for these engines to stop running. As you already know, on the footage, you can see a blue line extending out from the spacecraft, which is that little capsule-shaped marker. This is called the orbital trajectory, and it is used to calculate where you are on the orbital map. Right now, we have just jettisoned our third stage and are now moving on to Stage 4, or Block G in Russian. Now's the stage of the mission where we get into orbit, jettison our stage that we're on right now, and get ready for our lunar burn, or TLI. Now I'm going to explain how orbital physics works. There are 2 things you need to know about in an orbit: that there is an apogee, which is the highest point in an orbit, and the perigee, which is the lowest point in an orbit. Currently, we're approaching our apogee, and what we're supposed to do here is we're going to do something known as an apogee kick, which is basically burn the engine so that the perigee, the lowest point, is above the atmosphere. That is how you achieve an orbit. Now you may remember at the beginning of this section that I used the acronym TLI. What this means is translunar injection. In basic format, this would mean that the angle that your spacecraft would have to take from the Earth to the Moon would have to be at a 45-degree angle. Using your engines, you will be able to send your apogee upward towards this orbital plane at the 45-degree angle, and by the time you're up there, you will encounter the Moon like you see on the screen here. Now I take it on your screen that you see we are about to reach the Moon, or we are plotting out a course for it. Now you may be wondering, what are those strange other orbital lines? Well, to explain it simply, the blue line is the line that we're traveling with. The yellow line, which is the shortest one of the bunch, is what our encounter is going to be. You can actually see, if you look closely, a mock-up of where our perigee is going to be at the Moon. Our purple orbital line shows where we're going to end up after this encounter. And bada bing, bada boom. We are at the moon, and I don't know why I'm making up this tune. Continuing on, you can see that we have successfully entered orbit and we are about to commence our landing. What you see on screen right now is me getting one of our crew members, Valentina to be precise, on an EVA, or extravehicular activity. This basically means that I will take our crew members, or crew member, depending on how many, out of the spacecraft and send it into a different spacecraft, or just leave it out there and send it back into the same spacecraft. Right now, we have undocked from the Soyuz, and we are about to commence our landing. Hurrah! During this process, I am going to be lowering our periapsis, or perigee, it's called periapsis in this game, down towards the surface so that way it sends us on a collision trajectory. But we're going to make this into a landing trajectory. Right now, I'm just going to bring the spacecraft down and activate the engines. After that, I'm going to deploy the landing legs, jettison that bottom stage there, and use our main LK stage to finish the landing. Now this strange shape that my engine is facing right now on the nav ball is the retrograde marker. The retrograde marker, in basic terms, is the marker that has you facing backwards so that way you're canceling your velocity relative to something. Say, I wanted to bring a spacecraft down from orbit. You want to face retrograde. The opposite of that is prograde, which brings you up. Now that I have explained retrograde and prograde, we can finish our descent to the moon. Right now, you can see that we have just landed. Touchdown successful. The next thing I'm going to do is deploy some of the data antennas so that way we can communicate, and extend the ladder so that way we can get Valentina onto the surface. Now you may be wondering, why am I using the name Valentina to describe this character? Well, Valentina, in the game Kerbal Space Program, is meant to be an homage to the real female cosmonaut, Valentina Tereshkova. Now, the reason I'm saying cosmonaut is because that's what Russia called its astronauts. Now, Valentina Tereshkova was the first woman in space, launched from Earth's soil. Even though Valentina never made it to the moon, she achieved many great accomplishments for the Soviet Union during the space race, the first one of which I will explain right now. She was on a rocket in the Vostok program. The Vostok program was a manned space initiative made by the Soviets. And because of this, many female astronauts today are in space as we speak. Right now, as you can see, Valentina Kerman is climbing back into the LK so that she may rendezvous with the Soyuz, which is the module we undocked from before our descent, and get sent back home. Now, you may be wondering what a Soyuz is. That's the part I'm about to explain right now. The Soyuz was a Russian crew complex that was used during some orbital flights, including practicing orbital rendezvous. Orbital rendezvous is something that will be coming later. The Soyuz was also planned to be used in the mission that you are seeing on your screens right now. Now, coming along with us on this journey was the LK, which was the proposed Soviet moon lander that was going to be used to beat America to the final frontier. Now you may be wondering one more thing about the LK. Why did the landing legs just separate? This is to save weight in our orbital ascent, and this would have happened had this project come to fruition. Now what you can see now is said orbital ascent, as I keep a goal to dock with the Soyuz. Right now I'm just doing our gravity turn maneuver once again. And now you can see where our spacecraft is and where the Soyuz is, which is the other capsule marker orbiting around the gray line. Now you may be wondering, how does docking work? Well, docking works in somewhat like this. There's a docking port on both spacecraft, and these two will use a series of magnets and springs to attach to each other and then clamp to each other so that way crew can pass through. It's how the International Space Station was assembled. Now it's time to talk about what's going on with me setting up all of this and going towards our target. This works by adjusting our orbit to the point where eventually, after some go-arounds, we will be able to meet up at a close enough distance so that we can do said docking maneuver. After a few orbits and what is just basically a game of space tag, we are approaching our target. Now, in order to get closer to the target, we will need to burn retrograde from it, so that way we can cancel out all our velocity, and we will be still, in parallel to it. After we do that, we use our RCS thrusters, or reaction control thrusters, which are basically tiny rockets on the sides that help us with maneuvering, and we use those to get closer in a more slow and less crashy manner, and then dock. As you can see right now, I have just switched to our Soyuz, and I have set our target for the LK. And even though I didn't explain this, LK stands for Lunar Craft. Now that we have our targets facing each other, now that we know where our targets are, we can begin docking. Right now I'm using the Soyuz RCS thrusters to get us closer. Eventually, if you look really closely, you can actually see the LK in the darkness. I've just switched back to the LK, so both of our targets are facing towards each other. And basically this part is kind of a game of chicken, except the game of chicken is you trying to hit each other. Slowly. And as you can see, we have now docked. Hooray for that. We can now transfer Valentina back into the Soyuz and bring both our crew members back home. Okay, now that we have successfully docked to the Soyuz and Valentina has transferred back into said Soyuz, we can now undock the LK and go back to Earth. Okay, it is time to go back to the planet where this mission began, Earth. Now, what I'm doing here is a reversal of what I did when I tried to get to the moon. So that way our crew can come back and re-enter and safely be back on Earth's soil. You're about to see the safely be back on Earth's soil in the next section. Here we are, after a long journey through the final frontier, we have reached our destination, Earth. I'm going to explain how the re-entry system on the Soyuz works. As you saw just now on your screens, we have separated from the two modules that were on the bottom and top, respectively, the orbital module and service module. Now we get to see the heat shield in action. This works by protecting the rest of the capsule from the harsh elements of re-entry, which you're about to see right about now. Without a heat shield, it is highly likely that your capsule may explode in the upper atmosphere. And now, the drogue chute deploys, which is basically the parachute that slows down the spacecraft enough for the main parachute to deploy. So, that's basically what drogue chute means. After we cut the drogue chute, we can now watch as the main chute deploys and brings us safely down. And after the main parachute deploys, it is time for our final re-entry feature. What would this happen to be? Well, on the Soyuz, there were always these tiny solid fuel boosters, or tiny rockets on the bottom that would slow it down just enough so that we could end up landing safely without much of a bump. And there they are. They have just successfully activated, and one more thing, I hope you learned lots, I hope you enjoyed the video, and goodbye. Also, maybe you could try Kerbal Space Program for yourself one day. It's a pretty cool experience. Alright, see ya.